It started with a single ping that should not have existed. 3 weeks ago I was auditing a client's old network logs. The company had been bought out, the servers decommissioned, the IPs reassigned. Standard cleanup job. Boring work, until line 4281 of a 2017 log file lit up my screen. One outbound connection to an IP address that had been offline for 6 years. Duration, 0.4 seconds. Bytes sent, 18. Bytes received, 2047. Then nothing. No follow-up. No error. The destination IP belonged to a server that was physically unplugged in 2018. I checked. I called the old sysadmin. He laughed and sent me a photo of the dismantled rack. Empty. Dusty. Dead. So who answered the ping? That question cost me my sleep, 3 burner laptops, and a one-way ticket into a part of the internet most people pretend does not exist. Because when I tracked that phantom server, it led me somewhere still breathing. Still active. Still listening. And it knew I was looking. This is how you find a ghost on the internet. And why you might not want to. How dead servers talk. Let me explain why that log entry was impossible. When you decommission a server, 2 things happen. First, you wipe the drives or destroy them. Second, you release the IP address back to the data center or ISP. That IP gets reassigned to someone else. If you ping the old IP today, you should hit the new owner. Not the old machine. But this was different. The IP had not been reassigned. It was part of a reserved block owned by a defunct hosting company called Veraxon Data. Veraxon went bankrupt in 2019. Their AS number was revoked. Their entire IP range was marked as unroutable. BGP tables worldwide agreed, packets sent to that range should die at the nearest router. No reply. No response. Except this one did. I ran a traceroute. The packet went 12 hops, hit a dead end at a level 3 node in Frankfurt, and then, impossibly, jumped. Hop 13 was the target IP. Hop 14 was nothing. It was like watching someone walk into a brick wall and appear on the other side. Any network engineer will tell you that cannot happen. Unless someone is spoofing. Or tunneling. Or the server was never really offline. I needed to see if it was still there. The first knock: you do not port scan an IP that should not exist. Not from your home network. Not if you value staying off lists. I spun up a VPS in Iceland, routed it through 2 VPNs, and sent a single TCP/SAN packet to port 80. The most basic of hellos. It answered. SYNACK. My terminal froze for a second. A live HTTP service on a dead IP. I pulled the headers. Server, Apache/2.2.15, Unix, X powered by, Veraxon v1.3 last modified, Wednesday, February 15, 2017, 3:14 and 7 seconds Greenwich Mean Time. Apache February 2, 15 was released in 2010. End of life was 2017. Veraxon v1.3 was their custom control panel. It was discontinued when the company folded. And the last modified date was the exact day the company announced layoffs. The server was a time capsule. But time capsules do not send packets. I requested the root page. It returned 18 bytes. A blank HTML file with a comment, Node 7. That meant there were at least 6 others. Going deeper than Google at this point, I had a decision to make. I could report it to the regional internet registry and let them null route it for good. Or I could find out why a dead company's server was still running, hidden behind a wall of unroutable IP space. You can guess which one I picked. The surface web was useless. Veraxon had no website. Their domain expired in 2020. Archive.org had 3 captures, all of a placeholder page. But the deep web is different. The deep web is not Tor. It is not illegal markets. The deep web is just anything not indexed by search engines. Private databases. Old intranets. Forgotten dev servers. And sometimes, things people buried on purpose. I started with passive DNS. If anyone else had talked to this IP, their DNS resolvers might remember. I found 4 domains that pointed to it between 2014 and 2018. 3 were dead. 1 was still registered. VX-Node7-Relay.net registered through a Panamanian privacy service. No website. But the name servers were active. And they pointed to another IP. Also in Veraxon's dead range. Node 7 was not alone. It was a relay. I mapped the IPs. There were 8. Nodes 1 through 8. All responding. All running that same ancient Apache version. All returning 18 bytes with a different node comment. Except Node 4. Node 4 gave me 2047 bytes. The exact size of the payload from the 2017 log. The payload I requested it again. The server sent back a file with no extension. No headers except content type, application/octet stream. I did not open it on my main machine. I air-gapped a Raspberry Pi, loaded the file, and ran file on it. Data helpful. Hex dump showed the first 4 bytes, 7F45-4C46. An ELF binary. Linux executable. 64-bit. Stripped. From 2016. I threw it into a disassembler in a VM with no network. The program was small. Under 200 kilobytes. Its only function was to open a raw socket, listen for a specific 16-byte sequence, and if it received it, execute a second payload it downloaded from a hard-coded IP. The hard-coded IP was Node 1. This was a beacon. Node 4 was waiting for a wake-up call. And once it got it, it would reach out to Node 1 and pull down instructions. That 16-byte sequence? I had it. It was in the 2017 log. The 18 bytes sent to the Phantom server. That was the wake-up call. Someone had triggered Node 4 6 years ago. And Node 4 had downloaded 2047 bytes in response. I was holding the reply. Who built the ghost net? To understand why this exists, you need to know what Veraxon was. Officially, they were a mid-tier hosting company. Cheap dedicated servers. Mostly used by startups and crypto miners. Unofficially, they had a side business. In 2016, a leak from the shadow broker's dump mentioned a company called V that provided bulletproof relay infrastructure for a state actor. The description matched Veraxon. Small, financially unstable, with legacy IP space and no compliance department. Perfect for hiding in plain sight. Veraxon collapsed in 2019 after their CEO was indicted for fraud. Not espionage. Fraud. The indictment never mentioned servers. The FBI seized their office, but the hardware had already been auctioned off. Except, apparently, for 8 servers that were never on the books. These nodes were not in any data center. BGP does not lie. For a packet to reach a dead IP, something has to be announcing that route. And no one was. Unless the announcement was happening somewhere BGP does not see. Like inside another network. The network inside the network. I went back to that Traceroute. Hop 12 was the level 3 node in Frankfurt. Hop 13 was the phantom IP. What if Hop 12 was not the last public router? What if it was the entry point? Some ISPs run MPLS networks. Multi-protocol label switching. It lets them create private tunnels across the public internet. If Veraxon had a deal with Level 3 in 2016, they could have built a private MPLS path to a hidden rack. The world would see the IP as dead. But anyone inside Level 3's network with the right label could still reach it. That would explain the routing. But MPLS tunnels are not free. Someone had been paying the bills for 6 years after Veraxon died. I needed to see the network from the inside. So I did something stupid. I replayed the wake-up call. Waking the dead, I took the 18-byte sequence from the 2017 log and sent it to Node 4 from my Iceland VPS. For 5 minutes, nothing. Then my firewall lit up. An inbound connection from Node 1 to my VPS. On port 31337. It tried to push data. My VPS rejected it because I had no service listening. The connection died. 10 seconds later, Node 1 tried again. And again. 3 times total. Then it stopped. I had just told a hidden server network that I was active. And it tried to deliver something to me. I set up a Netcat listener and replayed the wake-up call. This time, Node 1 connected and dumped the payload. Another ELF binary. Larger. 1.8 megabytes. Its purpose was clear after 20 minutes of reversing. It was a relay controller. It turned whatever machine ran it into Node 9. The network was trying to recruit me. How big is the ghost if Node 4 waits for a wake-up, and Node 1 sends the controller? Then there must be a Node 0. The command node. I scanned the remaining nodes for open ports. Node 2 had SSH open. Old open SSH 5.3. Vulnerable to 3 different remote exploits from 2014. I should not have done it. I did. Inside Node 2 I found a mounted drive. 8 terabytes, full of dated directories. 2016/2017/ all the way to 2026/. The current year. The 2026 directory had files modified 3 days ago. This thing was not a relic. It was operational. The files were encrypted. AES-256. No keys. But the file names were not. Batch_4421.package uplink_confirm.log heartbeat.txt contained 1 line, updated every 10 minutes, all nodes nominal 8 nodes. All reporting. All alive. And there were logs of outbound connections. To IPs all over the world. Brazil. Vietnam. Ukraine. Kazakhstan. None of them were data centers. They were residential IPs. Consumer routers. Compromised IoT devices. The phantom server was not the ghost. It was the puppet master. The nodes were a command and control network. And it had been growing. What it does, I could not decrypt the batches. But I could see their sizes. 2 megabytes to 40 megabytes. And I could see where they were sent after being received. The logs showed forwarding to Tor exit nodes. To VPN endpoints. To Telegram bots. This was a data laundering system. Information goes in from hacked devices, gets bounced through the dead Veraxon IPs to break attribution, then gets pushed out to the open web. Who uses it? I found one clue. In the 2023 directory, a file named client_notes.txt. Unencrypted. It read, Client 7, payment received. 6-month extension. Maintain OPSEC. Do not use after September 1st, 2026. Network will be sinkholed. Sinkhold. That is what security researchers do when they take over a botnet. Someone plans to burn this network in September 2026. 8 months from now. Which means right now, someone is still paying for it. And someone else is hunting it. The moment it saw me after I pulled the logs from Node 2, I got sloppy. I left my Netcat listener open. An hour later, I got a new connection. Not from Node 1. From an IP in Ashburn, Virginia. AWS. It sent no data. It just opened and closed the connection. A knock. I checked the IP. It belonged to a cybersecurity firm that contracts with government agencies. The same firm that published a paper on sinkholing legacy C2 infrastructure last year. They knew I was in the network. The next day, Node 4 stopped responding. Then Node 5. One by one, the nodes went dark. Not from my doing. Someone was killing them. Or moving them. The relay. It is still up. Right now. Still returning. I think they left it as bait. Or as a warning. Why this matters: the internet forgets nothing, but it buries things well. Veraxon's ghost network was built to be forgotten. Unroutable IPs. Ancient software. No domains. It survived because no one looks for infrastructure that is officially dead. And it worked for at least 10 years. How many other ghost nets are out there? Built by companies that no longer exist, running on IP space no one audits, doing jobs no one will admit to. It is the space between the routers. The addresses that do not exist until they do. I did not report the network. I cannot. Because the moment I touched Node 2, I committed a crime. Unauthorized access. The cybersecurity firm knows my VPS IP. If they want me, they can find me. So I am leaving this here. If you know how to check, Node 7 is still active. vx-node7-relay.net resolves. It will answer a ping. It will serve you 18 bytes. But do not send the wake-up call. Because I do not know what happens after September 1st, 2026. I do not know if the sinkhole is for the network, or for anyone who finds it. And I am not going to be Node 9 to find out. Some ghosts are better left dead. Even when they are still breathing.